students. So welcome back to the geography class. And in this class, we are going to discuss about the causes of earth movements. And before we come to that, remember previously we are discussing about the earth movement itself under the introduction of internal land forming processes. And we had studied of how crustal rocks can be moved by different processes due to the earth movements, which were all about the movement of crustal rocks as a result of forces originating from the interior of the earth, which those forces we named them as, or we termed them as tectonic forces. And in this class today, we are going now to study of how those earth movements, or basically what causes the earth movements. And students, remember that we had two main types of earth movements which we had discussed earlier. The first one being vertical earth movements, and the second one being horizontal earth movements, whereby we had said that under vertical earth movements, we said this is where crustal rocks move along the vertical plane. That is either towards the earth's surface or towards the center of the earth. Basically, it's all about movement of crustal rocks along the radius of the earth. Then the other one was the horizontal earth movements, which we said this is where crustal rocks move along the horizontal plane. And we said for any crustal rock to move along the horizontal plane, it has to be due to the tectonic forces, which results the difference in the horizontal movement, whereby the three tectonic forces that we discussed was, one, we had tensional force, which we said it forces crustal rocks to move away from each other. That is tensional force. And then the second one, we had compressional force, which we said these are forces which push crustal rocks towards each other. Then eventually we had the shear force, which we said these are the forces which push crustal rocks past each other in opposite directions or in the same direction. That was under the horizontal earth movements. And in this class, I want us to study about the causes of earth movements. Here we shall be discussing what causes the earth to move from one, what causes the earth's crust actually to move either vertically or horizontally. What triggers that movement for crustal rocks to move either vertically or horizontally? And we are going to discuss these causes. We are going to discuss these causes under the four major causes. One, we have the magma movements. Magma movements, basically the movement of the magma. Two, we shall be discussing about gravitational force. How does gravitational force causes crustal rocks to move? Three, we shall be discussing about isostatic adjustments. We'll know what it is later on and how it causes the movement of crustal rocks. And eventually, we shall discuss the cause called convectional currents. How does convectional currents within the mantle causes crustal rocks to move either vertically or horizontally? So those are the major four causes which I want us to discuss during this class. And let's begin with the first one, magma movements. Magma movements within the earth's crust. And under magma movements, here we shall be discussing mostly how does movement of magma causes the earth's crust to move. And we all know magma can be forced to come out of the Earth's crust due to greater pressure in the mantle. Under the study of the internal structure of the Earth, we said that the magma is found in the layer called the mantle. And I remember we said that the mantle is just beneath the crust, and the crust being solid in nature, it is enclosing like a blanket. It is covering the magma. And we have discussed also that the interior of the Earth is very hot, and we all know hotness comes with developing pressure. When a hot substance is being covered, it develops what is called pressure. If you insert hot water in a jerry can and you close it, you realize that the pressure inside will develop. Possibly even the jerry can might swell up due to the greater pressure which is building up due to the hotness of that water, that air inside. And under this, when that pressure develops, magma which is inside the mantle, whenever it finds a line of weakness, it will be forced to come out now of the mantle, either into or onto the Earth's crust with a very high force. Basically, if this is the Earth's crust, let me just draw a portion of the Earth's crust. This is the Earth's surface, this is the Earth's crust, the solid parts, and we all know inside we have now the mantle. And as you remember, the mantle is made up of molten rocks. Molten rocks, which is semi-molten or liquid in nature, and they are very hot. When they are very hot, they build up pressure. When pressure increases, in case a line of weakness on the Earth's crust is developed, the magma in the mantle will be forced to come out with a very high force, leading to this crust to be dysfunctional, in that it can either force the crust to move vertically, making the upper parts, due to the force of this magma as it's being pushed to come out, it will push the crustal rocks to move upwards, causing an upwarping, or that force as the magma is being pushed or forced to come outwards, it will pull or push these crustal rocks just near that line of weakness to move horizontally, either towards the left or towards the right from that line of weakness. Basically, from that, we can tell that magma movement as a cause of earth movement, it is where the magma is being forced to come out of the mantle due to the high pressure, causing what? Either the Earth's crust to be pushed upwards or sideways by that magma when it is being forced to come out through that line of weakness. That is the first cause which magma movement can either cause, that vertical movement or horizontal movement. Then here it says that when magma moves from the reservoir, which is the mantle, and leaves empty spaces into which crustal rocks are pulled inwards, now that one introduces this other concept or cause, which is gravitational force. Let's come back here to this diagram. We have the Earth's crust. This is the Earth's crust, remember? The Earth's crust. Then we have the mantle where we find the magma. And now, in the aspect of this second cause, gravitational force, and how it causes earth movements, Gravitational force will only cause Earth movements when the magma which was removed to come out occupy space. Of course, we all know any matter occupies space, and therefore, after this magma has been ejected, after the magma has come out to the Earth's surface, that space which was occupied by the magma in the mantle, actually it is called the magma chamber. The magma chamber. After the magma has been pushed outwards, after that eruption has occurred, magma has been forced to move out from the mantle. Then we all know, as we have said, any matter occupies space, and that magma which was occupying a space in the mantle, the space that the magma was occupying will be left to be free. It's called a void, an empty magma chamber. The magma which was there, it has already erupted. It has already come out. Now that empty space, which is the empty magma chamber called the void, will be left empty. And now that is where the impact of gravitational force comes in. Previously, we had said that gravitational force, this is a force which pulls everything towards the center of the Earth, which is the core, right? That's gravitational force. It attracts everything in all directions, pulling them towards the center of the Earth. And now, the impact of that force will apply here, in that empty space, that void, the empty magma chamber, the space will need to be filled. And now, when gravitational force apply, it will basically pull the crustal rocks above the empty magma chamber, making them to subside and sink, so that it can occupy this empty magma chamber in such a way that all now the crustal rocks that were vertically above the empty magma chamber will be pulled downwards, occupying the empty magma chamber, leaving now this other part here to be empty, the upper parts, in that after the crustal rocks above have sink or subside so that they can occupy the empty magma chamber. If I may ask, between the vertical earth movement and the horizontal earth movement, which type of earth movement is being caused by this factor? It is the vertical earth movement due to that downwarping or the sinking of the earth crust as it occupies the empty magma chamber due to the influence of gravitational force. The next one, we have here isostatic adjustments. Isostatic adjustments as our third factor. Isostatic adjustments. Isostatic comes from the word isostasy. And isostasy, it has been defined as the state of balance between the seam and the seamer. That is what isostasy is. Isostasy. That state of balance. The states of balance between the seamer and the seer. And we all know the seamer and the seer was all about the continental crust and the oceanic crust, respectively. And isostasy is now that state of balance between the two, the continental crust and the oceanic crust, which now I want us now to discuss how does this state of balance, that isostatic adjustment, how does it result to Earth movements? We all know this small game we used to play. It's called a seesaw, right? Whereby we have one person sits here, another one here, then we have the fulcrum there. And it always works in such a way that where the heavier person is, that place will move down. Where the lighter person sits, that person is light, less weight, moving up, in that order. And that is the same way in which isostatic adjustment causes Earth movements. The crust is like a boat, is like this seesaw, floating on the mantle. Floating on the mantle. This is now the Earth's crust, floating on the mantle. And now, for any isostatic adjustment to apply, there has to be that state of imbalance for it to try and balance. In that, isostatic adjustments, for any imbalance to occur, they are caused by two major reasons. For any imbalance to occur, it is as a result of two major reasons. One, we have erosion, and two, we have ice melts. Ice melts and erosion. Ice melts and erosion, whereby for the crusts to have any imbalance, lack of imbalance is due to difference in weights. It is due to one, erosion, and two, ice melts, whereby erosion mostly they are caused by the agents of erosion, in which we all know it includes air or wind, we have water, we have ice, erosion. All these, they are some of the factors which cause erosion. But now, for erosion to cause an imbalance in this crustal rock which is floating on the mantle, it has to be due to the fact of either accumulation of substances, that is deposition for a long period of time, or the erosion itself, removal of parts of the crustal surfaces for a long period of time. Let's see how it works in this diagram that we have here. This is an illustration of a seesaw. When erosion takes place in this illustration of ours, which the crust is the upper parts, let's put this as prevailing winds. When prevailing winds takes place for a long period of time, the seesaw, remember, is the crust. It can be even the continent, Africa. When prevailing winds, let me say it's the northeast prevailing winds, when they take part for a long period of time, eroding materials from North Africa towards South Africa, continuous erosion for a long period of time will basically lead to more materials will be taken, picked from the northern part of Africa, taken by the wind and deposited towards the southern part of Africa. And now continuous erosion and continuous deposition will now lead to that state of imbalance. One side will be heavier, the other side will be lighter. Erosion is taking place on this side, deposition is taking place on this other side. And just from that, when erosion is taking place here and deposition is taking place here, after a long period of time, materials taken from these parts to these parts, these points will be lighter and these points will be heavier where deposition is taking place. And this basically will lead to that adjustment to take place, whereby the southern parts will be forced to sink in the mantle, while the northern parts will be forced to move upwards in that mantle, causing that balance to be there. The same as ice melts. And ice melts mostly occurs in tropical areas or polar regions, countries like the Greenland, where it is very cold, mostly towards the North Pole or the South Pole, whereby for any imbalance under ice melts, it is due to the change in seasons. Mostly the winter is the cold seasons, and during winter, there is a lot of ice accumulation, while during summer, there is a lot of ice melt. Summer is a warm season. So during winter, the cold season, ice accumulates. When ice accumulates, those areas, that crustal rock, they become heavier due to ice accumulation. When they become heavier, they will adjust, making it to sink. And the same place during summer, those ice will melt. When the ice accumulation melts due to the warmth in summer, then that place will become slightly lighter, making it again to adjust and move upwards. That is all about isostatic adjustment and how an imbalance caused by erosion and ice melt leads to the movement of Earth's crust as it tries to seek balance. The next one, we have convectional currents. And as you can see here, convectional currents within the mantle. We had said that the mantle is made up of magma, and magma, it is the semi-molten rocks which are found beneath the crust, and we said that they are very hot, and due to that factor, magma, they always move in convectional currents, circular motions within the crust, and as the magma moves, it causes the crustal rocks to move in the direction of the movement of the magma in the mantle due to that effect of convectional currents, whereby the magma which moves in a circular way beneath the Earth's crust, it causes what is called a frictional drag. It causes a frictional drag on the surface of the crustal rocks, causing them to move from one side to another depending with the direction of the convectional currents. From this illustration here, we can observe basically that we have magma in the mantle which is moving in that circular motion. This is convectional currents, and as they move, basically they result a convectional drag. Its contact with the crust results into a frictional drag which causes the crust to move from one direction to the other. This one mostly causes the horizontal type of movement, and that is how convectional currents causes Earth movements. That is how convectional currents causes Earth movements. So learners, those are the four causes of Earth movements that we have just discussed, and we have discussed how do they cause the crustal rocks to move. So one, we have talked about the convectional currents, which we have just finished, and it's all about that circular movement of magma beneath the mantle. Two, we have also talked about isostatic adjustments, which we have just said is all about that state of balance between the seal and the simmer. That is the oceanic crust and the continental crust, which we have said any imbalance is caused by two things. One, erosion, and two, ice melts, whereby whenever there is that difference in weights, then the earth crust will have to find now the balance. Then three, we have talked about gravitational force, and we have said gravitational force will only cause earth movement when the magma chambers are left empty, and when gravitational force applies, it pulls the crustal rocks above the magma chamber, forcing them to sink and fill up the space, causing the earth to move, the crustal rocks to move. Then the last one we discussed was the magma movement, which we said it is the magma which is being forced to come out. That force of magma, as it is being pushed to come out from the mantle, forces the magma, forces the crustal rocks to move, either vertically or horizontally. Either vertically or horizontally. Having learned the causes of earth movements, during our next session, we shall be explaining now the different theories which explains earth movements. The two earth movements, both the vertical earth movement and the horizontal earth movements. We have two theories which explains how does earth movements occur. One, we shall discuss about the continental drift theory, which it's all about the theory which explains how did the modern or how did the present day continents came to be by a meteorologist called Alfred Wegener. And number two, we shall be discussing about the plates tectonic theories. Here we shall be discussing of how plates or continental crusts and oceanic crust move either away from each other, towards each other, or past each other, depending with the impact of tectonic forces that we had discussed earlier. So let's mention something small about the continental drift theory. The continental drift theory. The continental drift theory was established by a meteorologist called Alfred Wegener in the year 1912. Whereby, under the continental drift theory, Alfred Wegener argued that the present day continents were once in form of one large continent. And we all know the continents that we have in our globe or planet Earth. We have Africa, we have North America, we have South America, we have Europe, we have Asia, and we have Australia. Those are the major continents that we have. And now, according to this theory of continental drift theory, Alfred Wegener said that the Earth's crusts are in a slow but steady movement continuously. And he argued that at some point in time, all these continents that we have today was in form of one large supercontinent called the Pangea. All the continents were in form of one large supercontinent called the Pangea. And by that, it basically means that if there was only one continent, one large mass of land, then there was also one ocean. So the large land was called the Pangea supercontinent, which was surrounded by one large ocean called the Panthalassa. This was the supercontinent. And we also had the ocean, one large ocean called the Panthalassa, which was now surrounding the Pangea. And due to gravitational force and the tectonic forces, the Pangaea broke into two. The Pangaea, that's one large mass of land, broke into two. One which drifted towards the north was called the Laurasia, and the one which drifted towards the south was called the Gondwanaland. Gondwanaland. Pangaea broke up into two. The Laurasia drifted towards the north, and the Gondwanaland, which drifted towards the south. And the two were separated by a narrow ocean called the Tethys. The two were separated by a narrow ocean called the Tethys, a narrow ocean which was separating the Laurasia and the Gondwanaland, in which the Tethys, it is actually the modern Mediterranean Sea. And we all know the Mediterranean Sea is separating the African plates and the Europe and Asia plates, or the Eurasian plates. Then Alfred Wegener continued to argue that due to the same forces, the tectonic forces and gravitational force, Laurasia now splitted into the modern northern continents, which is North America, Europe, and Asia. While Gondwanaland, the one which drifted towards the south, also splitted again into the southern continents, which is Africa, South America, Australia, and Antarctica. And I believe these are the present day continents. So basically, according to Alfred Wegener, all the continents were one, which was the Pangaea. Due to the forces, they splitted into two, Laurasia drifting towards the north and Gondwanaland drifting towards the south. Then the two were separated by a narrow ocean called the Tethys. Then, due to the same forces again, Laurasia splitted into North America, Europe, and Asia, while Gondwanaland splitted into Africa, South America, Australia, and Antarctica. So that is how the 7 present-day continents came to be, as a result of what? This theory called the continental drift theory by Alfred Wegener. So during the next session, learners will speak about the proofs which support this continental drift theory by Alfred Wegener. What were the arguments that he made to prove that indeed the continents were once one large supercontinent called the Pangaea, and what shows that indeed these continents splitted with time until the formation of the 7 different continents that we have today. So thank you so much, learners. God bless you so much. Continue going through this theory of continental drift theory. Until next time, have a good day.